Junior Cycle Higher Level 2014 Phase 3 Paper 1 Question 3. This is a sets question, and they give you a series of sets with various different digits in, and you're asked to complete the Venn diagram. So what they're asking you to do is put each of these numbers to put them in the appropriate places inside this 3-set Venn diagram. Note that there's no universal set, so we're assuming that whatever numbers we have here, that's the entirety of it, and there's no other numbers that's going on around outside. So when you're asked to put a set of elements into a Venn diagram, the first thing you should try and do is work out the elements that are in various different intersections. So I'm noticing, for example, that 2 appears in both A and B, but doesn't appear in C. So it's in the intersection of A and B, but not C. So it's in this section here. 4 is appearing in all 3 of them. 6 appears in A and B. 8 appears in B and C. So B and C, the intersection of B and C is here, but we don't want it to be in A because it's not in A at all, so it's going to be in this section here. And we can note that the other numbers, 3, 5, 10, 1, 12 and 14, aren't appearing more than once. So they're going to be in the sections where there are not intersections. So the 3 and the 5 go in A only. The 10 goes in B only, and the 12 and 14 go in C only. And it's worthwhile just checking, so A, do we have all those elements inside A? 2, 3, 4, 5, 6, we do. Do we have all these elements, which are all the even numbers, 2, 4, 6, 8, 10 in B? 2, 4, 6, 8, 10, yes. And in C, do we have all these numbers, 1, 4, 8, 12 and 14? Okay, hang on, I missed off the 1. It's good that we noticed that. Okay, 1 is also in C only, and we now have 1, 4, 8, 12 and 14. So we have all our elements, and we've double checked to make sure that we've got all the elements that are listed are appearing in the Venn diagram, and also we're double checking to notice that no numbers appear more than once. Each of these are appearing only once within inside this Venn diagram. So moving on, we've got we're asked to find out what is in A intersection B. So A intersection B is this section here. So we have the elements 2, 4 and 6. The next part is B less A intersection C. So the first thing we need to do whenever we have any sort of expressions like this, we always look at what's inside the brackets first to get a sense of that section before we deal with the expression in its entirety. So A intersection C, so A intersection C is this section here. And what we're being asked is to take this section away from B. This sign here means less. So B less A intersection C. So if you look at what B is the entirety of this circle here. Everything inside this circle is in B, and we're taking away the A intersection C. So we have this section here, these 3 subsections. And we have 2, 6, 8 and 10. And for the last question, we're looking at the union of 2 subsets. So we'll look at each of them. B less A, that's everything that's in B that's not in A. So it's like, so we say we're taking A away from B. And we have B less A, so B, and we're going to take away from that everything that's in C. And because we're wanting the union of those 2 sections, we're just taking all of those. So we've got, similar to the last one, we've actually got the elements 2, 6, 8 and 10 in these sections here. And you'll see it's the same as the previous answer. It's quite common for you to be able to describe a certain section in a variety of different ways. So in the first section we're just talking about the entire of B, take away this section, and the second one we're talking about two sort of moon shapes which overlap, but together they make the same shape as the first one, as the second one that was here. Lastly, for part A, we're asked write down a null set. So where in this diagram here do we have a null set? Well, you can see, you should have noticed that one of our sections of our Venn diagram was empty, this section here. So all we need to do is try and describe it somehow. And again, there are a variety of different ways, but the best way is to say, well, we've got this overlap, this intersection of A and C, but we want to take away this section here, the section that's for all sections. But by taking away B away from this intersection of A and C, we'll get the section that we want. So we have A intersection C, and from that I want to take away anything that is in B. And we say that as A intersection C less B. Moving on to part B, we're asked to look at a scenario. These questions are involving the two sets, M and N, Team M, Team N, and they're talking about a series of questions that were asked and how many were answered correctly. Team M answered 72 correctly, and Team N answered 38 correctly out of the 100 in total that were asked. So we've used that set of information that we've been given. Now, it won't take you too long to realise that if I were to add 72 up and a 38 up, it comes to more than 100. So we have a situation where we do have an overlap. Now, we also don't know how many will be outside of here, i.e. how many questions were correct, so answered incorrectly by both teams. Let's quickly talk about this. This is the section which will contain the questions that M answered correctly, but N didn't. This section here will be the section that will give me the questions that N answered correctly, but M didn't. This will contain all the questions that both teams answered correctly, and outside would be the ones that were answered incorrectly by both teams. And the questions asking what's the minimum number that could be answered correctly by both teams. So what's the smallest number I could possibly put it in this section here, such that the mathematics of it will still add up and the entirety of the universal set will remain as 100. Well, I can't put 0, because I can't put 0 in there, because if I did, then I'd have to say 72 were answered by M only and 38 were answered by N only. And as I've already said, those three numbers don't add up to make 100, they add up to actually make 110. So that's not an option. In fact, if you think about it, if I add those two numbers up, I get 110. Therefore, I'm definitely counting at least 10 questions twice. Therefore, I need at least 10 in the intersection, and 62 and 28 in the M less N and N less M. And that, as a sum, if I add those three numbers up, I would get 100. And that would mean that I'd have to have 0 questions left completely incorrect by both teams. And my answer is 10. It then asks a similar question, but this time it's a maximum number of questions answered correctly by both teams. So what's the maximum number I can put in here? Well, to some extent, what's happening here is I'm for the minimum number in the intersection, I'm trying to put as many in these only sections. For the maximum, I'm trying to put as much in the middle and as little as possible in the outside sections. So what's the most I can put in here? Well, I've got 38 for N. So I suppose the most, and 72 for M. Now, 38 is less than 72, so it wouldn't be difficult for me to put 38 in its entirety in that intersection, put 0 in N only, and then all I need to do is add an extra 34 for M only, and that will give me the 72 for M and the 38 for N. All I need to do is make sure that it adds up to make 100, and I can do that by putting 28 questions unanswered by both teams. And my maximum would be 38.